The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. When the James Webb Space Pluto Telescope turned its ultra-sensitive eyes toward Pluto, no one quite expected what it would see. The images that came back weren't just better, they were revolutionary. For decades, Pluto has been a distant enigma shrouded in mystery and icy darkness. Even with the incredible flyby of NASA's New Horizons mission in 2015, we still had more questions than answers. But with Webb's powerful infrared capabilities and high resolution, we are now seeing Pluto in a clarity never before possible, and the implications of this new data are staggering. Pluto, once considered the ninth planet of our solar system, continues to captivate scientists and space enthusiasts alike. Located in the Kuiper Belt more than 3.66 billion miles from Earth, this dwarf planet has long been a challenge to study in detail. Traditional telescopes, even the legendary Hubble, could only offer blurry glimpses of its surface, but the James Webb Space Telescope has changed the game. With its 6.5 mm gold-coated mirror and position beyond Earth's atmosphere, Webb captures light from distant objects with unprecedented precision. When it focused on Pluto, the resulting image revealed textures, features, and atmospheric details never before observed. What makes this achievement even more incredible is the way Webb works. Unlike visible light telescopes, Webb primarily observes the universe in infrared wavelengths. This means it can detect heat signatures and subtle variations in temperature and composition that optical telescopes simply can't, in Pluto's case. This allows scientists to peer through its thin atmosphere and detect changes in surface ice and potential geological activity. The new image released by NASA and the European Space Agency shows intricate details of Pluto's nitrogen ice plains, mountainous regions, and possibly even seasonal changes in its atmosphere. One of the most stunning revelations from the new Webb image is the sheer detail of Sputnik Planitia, the heart-shaped region on Pluto's surface. This icy plain, composed mostly of nitrogen, was first captured by New Horizons in 2015, but Webb's infrared sensitivity shows depth and texture that were previously invisible. Variations in brightness across the plain suggest ongoing surface processes, perhaps even sublimation or deposition of ice, indicating that Pluto may still be geologically active despite its small size and frigid environment. Webb's data also allows researchers to study Pluto's thin atmosphere in ways never possible before. Composed primarily of nitrogen with traces of methane and carbon monoxide, Pluto's atmosphere is tenuous and cold, but in the infrared, subtle shifts in temperature and composition become more apparent. Scientists are now able to trace changes in atmospheric pressure and temperature over time, offering clues about Pluto's seasonal cycles, which occur over its 248-year orbit around the Sun. But it's not just Pluto's surface and atmosphere that are under scrutiny. Webb's powerful instruments have also captured new details about its 5 known moons, particularly Charon, the largest and closest. Charon has long intrigued scientists due to its size half the diameter of Pluto and its synchronous orbit, meaning the same side always faces Pluto. Webb's imaging has revealed fresh insights into Charon's surface composition, showing possible signs of frozen ammonia, complex hydrocarbons, and changes in its crust that could suggest a more dynamic geological history than previously thought. Beyond Charon, the telescope has also observed Pluto's smaller moonsticks, Nix, Kerberos, and Hydra. These tiny, irregularly shaped bodies have often eluded detailed study due to their distance and size, but with Webb's help, scientists can now refine their orbits, estimate their surface compositions, and better understand their origins. All of this contributes to a deeper understanding of the entire Pluto system and the dynamic processes at play in the outer solar system. What's even more fascinating is how this image reopens the debate about Pluto's planetary status. Although the International Astronomical Union reclassified Pluto as a dwarf planet in 2006, the new data from Webb showcases its complexity. An active geology challenging the assumptions that led to its demotion. Many astronomers argue that Pluto exhibits characteristics more commonly associated with full-fledged planets, including layered geology, an atmosphere, and even potential subsurface oceans. This high-resolution observation also highlights the importance of continuing to explore the Kuiper Belt. Pluto is just one of thousands of icy bodies orbiting the Sun beyond Neptune. With Webb's clarity, researchers can now target similar objects with greater accuracy. This includes other dwarf planets like Eris, Makemake, and Haumea, as well as mysterious objects still waiting to be discovered. Each new image adds a piece to the puzzle of how our solar system formed and evolved over billions of years. The James Webb Space Telescope is more than just a new set of eyes in the sky. It represents a leap in how we observe and understand the universe. Unlike Hubble, which focused mainly on optical and ultraviolet wavelengths, Webb's infrared capabilities allow it to pierce through dust, detect faint heat sources, and reveal objects too cold or distant to be seen before. This is especially valuable when studying distant icy worlds like Pluto, which emit very little visible light but still shine brightly in the infrared. Webb's success in imaging Pluto also pushes the boundaries of what space telescopes can do. Its ability to precisely track and focus on a fast-moving, distant object like Pluto showcases an extraordinary level of engineering. Capturing such a detailed image required Webb's fine guidance sensors to operate with incredible accuracy, compensating for both the spacecraft's own motion and Pluto's slow drift against the backdrop of stars. This level of precision highlights Webb's versatility. Not only can it look back billions of years into the early universe, but it can also deliver crisp, insightful data from our own solar system. The telescope's unique strength lies in its ability to shift from exploring the most ancient galaxies to targeting icy, dynamic worlds much closer to home. This opens up exciting possibilities for future studies of other distant objects like Triton, Neptune's mysterious moon, or Eris, another large Kuiper Belt object. With each new observation, Webb expands our understanding of the solar system's farthest reaches, an area still vastly unexplored and filled with potential discoveries. As scientists continue to analyze Webb's data on Pluto, new questions are taking shape. Is there a hidden subsurface ocean beneath Pluto's icy shell, similar to those suspected on moons like Europa and Enceladus? What powers the apparent geological activity on a world so distant and cold? Are there cryovolcanoes reshaping the landscape, releasing volatile compounds from the interior? Webb can't answer all of these questions alone, but it helps frame them more clearly, offering vital clues that can guide the next generation of missions and theories. Another exciting outcome of Webb's detailed imaging is the growing opportunity for comparative planetology. By studying Pluto alongside other icy worlds, scientists can identify common patterns and differences that help explain broader processes. For instance, how does Pluto's nitrogen cycle compare to that of Triton? Are the organic compounds found on Pluto similar to those on Titan? Is there evidence in Pluto's crust that points to ancient collisions or a chaotic early history in the Kuiper Belt? These comparisons deepen our understanding of planetary evolution, not just in our solar system, but also in the exoplanet systems Webb is designed to study. Yet perhaps the most profound impact of this new image lies not in the scientific data, but in what it represents to humanity. Just a few decades ago, Pluto was a blurry, featureless dot in even our best telescopes. It was mysterious, distant, and largely unknowable. Now, with the incredible capabilities of the James Webb Space Telescope, we can see its icy plains, rugged mountains, and delicate atmosphere in astonishing detail. We can trace patterns in its frozen heart and glimpse the slow dance of its moons. We can begin to tell its story. This isn't just progress in planetary science, it's a powerful testament to human curiosity and determination. Every breakthrough image, every set of data is the result of decades of work of scientists, engineers, astronomers, and dreamers, all reaching beyond what seemed possible. Webb's image of Pluto is a reminder that the universe is always ready to reveal something new if we have the tools and the will to look. So, as we gaze at this beautifully clear picture of Pluto, we're reminded of the journey from its discovery in 1930, to the flyby of new horizons, and now to this next chapter. With Webb, it's a story of exploration, innovation, and the unending quest to understand the cosmos, and it's far from over. With each observation, Webb is not just capturing light from across the universe, it's illuminating the path forward. The James Webb Space Telescope's image of Pluto marks a new era in our understanding of the outer solar system. It's not just a picture, it's a revelation. A glimpse into a world once thought too distant to ever know, now brought vividly into focus. And it's a promise that as long as we keep reaching, the universe will keep answering. Asterisk.